live, right? Let me arrange my desk here a little bit.
You can't get enough charge.
Whoa, I don't want to see that still. Let's see. Yeah, we are live. Awesome. Awesomeness. Awesome. Who's there already? I see people here already. And MES. Hello. Mary boy. Bob. Oh, you're having a storm? Bob? Here it's sunny. There's no storms here. Hey Martin. I'm from Mexico. Hello to Argentina. Let me close a few things. How are you guys? How was your week? I've been having a bunch of fun programming some Tab 2 stuff. I made some serious changes and got into a mess, but I'm getting there. Okay. Hold on. All right. Yeah, Mexico won that game. Cool. Not a huge soccer fan, football, but I do watch when Mexico plays and sometimes. So that was good. That happened. All right, so let me see, where's my window? I'm missing stuff today. All right, here it is. Perfect. So there's a few things I want to talk about today, everyone. First one is that Tab 2 is being in, if you are Tab 2 or if you own Tab 2, you've seen that updates have been a little bit slow because I've been doing some refactoring in the code. But I'm happy to announce that it's working again. So let me show you. That's the screen is good. I think this is a little bit too over there. There we go. Okay, so you can see Tab 2 is there again. It looks the same. As it did, but it has some new things. Especially it's faster. It's now super mega fast. You can see it's super fast. I don't know why. Oh, there's no police here. Super fast search. The search is just incredibly faster, and that was the thing that I was actually changing because it was getting a little bit slow. So I made it, optimize it so it's super fast, and now it's working pretty cool. It's pretty cool, and there's a bunch of options that I need to work on. There's a bunch of code that I'm behind on the tool. I have some code already written for this that I haven't included, so I need to get into that. But this week we'll surely have a new update. Maybe the new history would be there. I don't know. I need to fix a few things in history, but if it's ready, it will be available. Alright, so There's another thing that I want to start on, and that is Linux. So let me bring a window here. Ubuntu.org. So this is the Linux distribution that I'm using at the moment, and it's actually the one that I'm recommending lately because it's really useful, really useful. If you are like someone that is not a big studio and want to use Linux, you should use Ubuntu. It's great. The KDE desktop, it's really nice for everything. It has a lot of tools useful for us that do graphics and stuff and manage files and all that stuff. It's pretty fast and all those things. And it doesn't use any GPU for the Windows or whatever. It leaves your GPU alone, which is something I really like. And the reason I'm mentioning this is because I'm going to start a free Linux series, like going into installing Ubuntu, configuring Ubuntu the way I use it for Houdini, and maybe use Maya or something. And a lot of other tools that you might want to set up, like Nuke or Fusion, or installing NVIDIA drivers and all that stuff that you do. And that it's going to be available for free in the YouTube channel. But what I'm going to do is offer a paid option for support. So if you want to have someone to help you with your Ubuntu installation or your Linux issues, I'm gonna have a paid option for support. Again, it's just gonna be optional. If you just want to see the videos and do everything yourself, it's great. But for those that might need a little bit of help, or want to have someone there that can help them, that is gonna be an option now. So, because I've heard a lot of people said, yeah, Linux is cool, but you need to have an IT department or whatever. It's not really true, but some people might need some help getting to it. So that's what I'm going to offer there. So that's that. Hey, Sergey-san and Shreko, Felipe, what's up? Shreko and Felipe, what's up, guys? So that's that. Also, remember that let's go to mixed training. That we have some training there. I'm preparing some new training that's also coming really soon. And so if you want to support us with this stuff, please go buy some training from us. It really helps us. And Tab 2, our tool, that it's a really nice tool that we made. It's gonna be that price for the time being, 25. You can get it for 25, or pay whatever you want. And that's it. Let's talk about Houdini now. Let's talk about Houdini. And let's see what we can do here. I want to talk a little bit of a simulation. Hey, Ellen Cran. What's up, Riz? Justin saying, what's the Linux distros most popular with big studios? I think the two big ones are Red Hat and CentOS. And that's because I'm gonna tell you why. The reason most people use Red Hat or CentOS is because a software like Maya is developed on Red Hat, and the reason is that it's the only real distribution that has support, so you have to pay for support for Red Hat. So there's a company that takes your money and helps you if you have any issues. So that's why companies like Autodesk are using Red Hat to develop Maya and their apps, and that's why the Foundry or other companies are using Red Hat to develop their applications, and then they only say, well, we only support Red Hat because they are developing in that platform. And the reason is because they can buy support. That's the reason why they use it. Okay, and Red Hat says our platform is solid, it's stable, you can pay us to help you with support, and that's what we are here for. Okay, so let me switch the big cam while I discuss this. And that's the reason. And why other people use CentOS is because Linux is GPL, it's free. So CentOS just takes the distribution of Red Hat, removes the logos, removes any Red Hat trace in the distribution, and redistributes that as CentOS. So inside, CentOS is basically exactly the same as Red Hat, but without the support. So you don't have any support with CentOS. You can't buy support for CentOS as far as I know from them. I don't think you can buy support from them, but you can hire in a studio like MPC. Felipe is saying they use CentOS at MPC. You have people there that take care of your issues and stuff. So that's why people use either Red Hat or CentOS, and that's why some of the applications like Houdini is not so only done in CentOS. I think they develop on CentOS, but a lot of people use Ubuntu for Houdini, and they do support it. Houdini is very not dependent on one distro. So yeah, Alan says that ILM is using CentOS. Yeah, so it's basically that's the reason why they use it, but it's not because CentOS is better than Ubuntu or better Linux. It's a better Linux than Linux Mint or Kubuntu. Is not the reason. The reason is that one. But if you use Linux in CentOS or Ubuntu or Kubuntu or Debian, it would be almost exactly the same thing. Talking about performance and in drivers and in graphics, graphics card, RAM, all that stuff will be basically the same. But the advantage comes from when you are something like me, that I have my own setup and I don't have to depend on giving support to 100 artists, that I want to have everybody needs to have the same system. I can use what serves me the most, because as I said before, there's I have audio interfaces that you don't have at a studio, microphones that you don't have at a studio, 4K monitors that you might or not might have at a studio, cameras, etc. And those things are supported better in recent Linux kernels, which is how Linux distributes the new supports and stuff for the system. So the new kernels have support for new audio interfaces, monitors, etc., etc. And CentOS is really, really, really old. old kernels. And sometimes it doesn't work. Okay, of course, the applications that are made in CentOS or Red Hat in this case, they work because they have the libraries that they need to work and whatever. Doesn't mean is the best application for them or the best distribution for them, but that's why they did it. That's the distribution they used to do it. They compile it with those old libraries, and then when you want to install some of those applications in newer distributions, they fail because they are compiled with old versions of libraries, and that's crap. I don't really subscribe to that. It's like, let's say I'm developing applications for Windows, and I'm doing it with the old Windows 7, let's say Windows 7 libraries, and you're gonna have an old really hard time using it in Windows 10, which is nonsense to me. I don't know why they do it like that. But okay, but that doesn't mean those applications don't work in current versions of Linux or current kernels. They might even work better because the new kernels have resolved issues that the old kernels don't have. And there's a bunch of libraries that are now new. They have fixes, and they are better supported or whatever, or newer compilers, etc. But okay, but it's still good. CentOS 7 is not that bad, but it's still old technology. So that's my with Linux rant there. So, and that's why I use newer versions, because that's what works for me. And also another thing is that if you learn just about any Linux distribution, it will serve you to use in any studio or whatever. If you I want to learn Linux for a studio, just learn whatever version of it, and you will be good. You don't have to learn CentOS or whatever, or CentOS, however you want to call it. Alright, so let's start talking a little bit about multi-solvers, because that's where we are here today. If you guys have any questions, just let me know anytime. Okay, so I want to talk not only about multi-solvers, but also about some other things in DOPS. So let's create a torus. I love toruses. I love him. Let's just rotate this guy. What am I pressing? Alright, I moved that in here. I don't want to do that. Okay. I want to just rotate this just to make it bounce, whatever. And let's create a collision plane, and let's go to DOPS. So there's I didn't make that DOP object, right? So rigid body is hero object, whatever. Go, and now it simulates whatever. It's not important right now. It just simulates. That's really simple stuff to do. I didn't make Houdini bigger today, and I'm not even showing you what I'm doing. All right, so there it is. It's just a torus that falls, but that is the non-important part. The important part is we're gonna talk about a few things here. So, and something that a lot of people don't even consider is these menus here. It's like, what are these menus? I've never used those menus, and I don't even want to know what they are for. Well, these menus are actually important because sometimes you want to do things in simulation that require, let's say, keyframing gravity. Let's say you want to keyframe gravity, and let's try it. Let's say that we want gravity going down, and then after 24 frames I want gravity going up. So let's put a keyframe on that. I'll click on that, let's put a keyframe, and after 24 frames and up to, let's say, 30, I want gravity to go the other direction. 9.8 is going up. See, it's pointing up there. And now let's try it. It didn't work. Did it? You can see the gravity is pointing down there, and then it points up. So what the hell? It should work, but it's not. So when you are in simulation land or DOPS or dynamics, there's a few, let's say, modes. There's a few modes you can control stuff. Okay, so when you prepare a simulation, you set your simulation, you set parameters and everything, and then when you run it, all those settings are passed to the simulation. Let's say it's the initial state, initial velocity, initial everything, and then after that the simulation takes over. So your let's say the gravity, you already told me the gravity, it's going 9.8 meters down. I'm gonna use that, and you can't change gravity after the initial frame, let's say. And that's why by default most of these parameters are always by default. You can see it here. This drop down applies to this row, right? And it applies to this row here. So this is consider this as a row and a row. So this is the behavior of this row, and by default it's using the default, and the default operation is here, down here. Default operation is setting the initial value, and that's it. I'm just gonna say, all right, give me the initial value, and after that you're not gonna be able to really change it. You can, but if I'm the dynamic solver, I'm gonna just ignore it. Okay, so that's how it's working by default. So it's just saying 9.8 going down. Okay, after this frame, that's what I'm gonna use, and I'm gonna solve everything else, and the result's gonna be whatever it is. But if you really want to animate this parameter, you can change the default here. You can say set initial will be the same as this, which is just setting at when the simulation starts, sets the value, and then that's it. You can set it to never, and this value is not gonna work, it's not gonna do anything. But if you set it to always, what's gonna happen is that at each frame it's gonna read this value, and then I say, okay, you want 9.8, okay, frame, plap, calculate the frame, and what do you want to do in this frame? Again 9.8, okay, 9.8, bing, again 9.8 again, okay. But you can see if we run this now, let's run the simulation setting this to set always. You can see now gravity changes, right? So now we can control gravity, we can keyframe gravity, and it's gonna work. So now we can actually, let's say, keyframe it down again here. Another keyframe there. You can see now gravity, it's changing, and it's making a mess with that torus there. We can even, let's say, let's do something a little bit more crazy, like delete channels, sign of simulation frame times 10. So now you can see it's going up, and then it should be going down now. It's going down, and where's the torus? Didn't came, so let's multiply the frequency here times 10. That's gonna be a little bit more crazy. Now you can see that. Oh, I know the sign is not giving us just giving us positive values. No, that's weird, because it is giving us it's giving us negative values, but it's just not going down. I don't know why. So that's if you want to do that, you can do that. But again, your simulation is gonna be heavier because it's always gonna evaluate that parameter instead of just making it a takeover and then just do whatever it wants to do. Let's try that. It's not falling. Maybe it's because it's too fast. Let's try that. I think it's the impulse is too much, and then it just doesn't go down. Whatever. So that's the idea with these parameters here. And you can see these guys are all over the place, not here, but in mostly in the in solvers and stuff. Let's create a magnet in solvers. In modifiers, you can see the magnet here can be changed and all that stuff. And by default, most of these, I think all of them are actually set to just set initial value, and that's that. So I wanted to talk about that because some people don't know that, and then they start asking like, oh, how can I animate gravity or animate some other thing, and they don't know why it's not working and stuff like that. And well, now you know. So now let's put gravity to initial thingy and then delete this channel. 9.8. Okay, so now gravity is gonna just act like it does. But let's do, you know what? Let's do a particle simulation for the next part, because we're now gonna talk about the multi-solver, which is basically the base of every solver. The multi-solver is just the base of all solvers, if I'm not mistaken there. So let's emit particles from this guy, and it's gonna emit. We're not gonna do a collision plane. Let's just leave it like as that. So let's see, we have that particles are falling, there's nothing stopping them, whatever, right? So what we can do is actually, if we go inside this pop solver and look around, you can see the last node here it's a multi-solver. Ooh, what does that mean? All right, so we can actually create a multi-solver here anytime. And it has two inputs. So the first input, it's going to be the object that's going to be processed, as you can read there. And in this case is this guy. You can see this is the gray input, and here has like a multi input, and it shows us that can accept all the stuff there. You can see it accepts basically all the solvers and advections and all the things that move around geometry or volumes or whatever are accepted here in this input. So what we're gonna do here is we are going to connect with, this is the source. Okay, we're gonna connect the source last, is it? This solver, let's delete this merge. We don't need that merge. We have extra merges there. So let's put this guy there, and then this guy here, and this is gonna take the source. Yeah, okay. So there we go. You can see now we have basically the same thing. We have the same thing here, but we're passing this to a multi-solver here. Well, so what is this? What does this mean? Is this means we can do something crazy here? Well, you can, and something very common is that you use a sub-solver actually. Let's create a sub-solver here, and then you plug it here into the multi-solver as well. By default it's gonna do nothing, because if you go inside here you can see the dot geometry, which is actually just points, do nothing. But you can do whatever you want here. Let's say we create a group GRP, group. You create a group and you can group points here. You can set a bounding region and just group some stuff with this. Let's make it to a sphere, and let's put it over here. You can see now I'm grouping some points there. I can do whatever I can do with in subs here. Basically, that's why people like this subsolver, because you can basically do whatever you can do in subs, you can do to simulation here. So this color is only gonna apply to my group. You can see I'm grouping some points there. Let's make this a little bit bigger, and there we go. You can see, let's hide the guide. I'm grouping some points, and if we run this, every point that it's and touching that sphere is gonna get red color. So some people find this more intuitive if you already know subs, because you can modify geometry like this way. You can also, let's say I want these points that touch this thing to have a velocity going in the other direction, let's say. So we can do that. Let's put random velocities to make it random velocities. AA said, have you talked about Maps plugin? I haven't talked about it. Would you be demoing it? I could demo it, but I haven't played with it much. I have it installed. You can see there, or at least one of the versions. I'm not sure if there's newer versions, but we can try it if you want here in the stream. We can try it. Let's randomize the n, and only for that group as well, and then do it inside a sphere. And then now if we run the simulation, and see now that is not too, let's make it affect more. Oh, I'm just affecting the normals, not the velocity, sorry. Velocity. Now you can see everything that's touching that, now it's too much. Everything that it's touching that sphere, it's having a random velocity there, which is it's great, because basically you're kind of working like if it was simulation, I mean subs land, because it is, but on top of a simulation. And if you don't know, this subsolver is basically what happens in, if let's say let's create a grid. A lot of people these days love the solver here in subs, and this guy is basically it's actually encapsulating a solver with a subsolver inside, which is basically exactly what we did here. It's a dot network with a subsolver. This guy is exactly the same. You can see if we go inside, you can see there it just has some code embedded to jump you to this step. But if you cheat here, you can see inside is a dot network, and then if you go inside, there is just an empty object and a sub geometry, and then there's a subsolver. If you go inside the subsolver, that's what you do. And this is exactly the same thing. They just encapsulated it. It's kind of an HDA at sub level, and then they did this there. But that's what's happening here. It's just using a subsolver inside there. So now you can do whatever you want with this. If you don't want to have these particles being random, you can do whatever. You can group them and use them here. Let's say let's call this red group for some reason, And we have the group here, actually, red group. Let's see if we can actually control them here. Let's add a pop force and see if we can actually use that red group. You can see we have a red group here. And let's give it an amplitude in the X direction. Let's go to 5. And I think it's working. Let's make it higher. You can see now those particles are actually shooting to the side because I'm controlling that here in several ways. Let's make it go up as well. So now you can see we have that, and it's so useful to be able to do stuff like this because for one thing it's really comfortable or kind of feels like home to be working in subs, because I'm just grouping these guys. Did I lose the yeah, because I changed the name of the group. Yeah, okay, so now it should be red again. There we go. So for one thing, you're working basically in subs, and you're passing that data back to simulation. You can see the group that I'm creating inside here. Yeah, I can use it here in a pop network here. And this is like, what? Can you do that? And yes, you can do that. There is an order here. So this is being calculated first and then this. So let's say at frame 1, this thing might not move as it should, but then it's gonna pick maybe at the second iteration, or at least that's how I understand this. Let me know if I'm wrong, but I think the order of these values those matter. You can see we can actually put it up, and you can see there particles are not red at the first frame, and then at frame 2 it does become red. So maybe I'm mistaken and the order is backwards like this. I don't know, but there is some order here. So because if I put it here, it is red at the first frame. So it is important for that to be in the right order. Sometimes, most of the time you might not need it. But yeah, you can do whatever you want with this stuff. Or even, let's say we want to stop particles that go to the ground plane. Let's say, let me see, how can I do that? Let's create a wrangle. And if, let's say that if position y it's less than 0, there's supposed to be curly brackets here, right? Let's set the position in y to 0. So let's see if it works, because I need a parenthesis. Been doing a lot of Python. So there we go. So now if we do that, you can see now we kind of just built our own imaginary plane there by a multi-solver, which is, at the end of the day, it's exactly what happens inside solvers. Even if we, let's say, create a pyro solver, let's create a pyro solver, and if we go inside the pyro solver, let me just unlock this so we can see what's happening inside. You can see there's a bunch of stuff here, but it is not as scary as you might think. If you go here, you can see now there is a smoke solver there. But if you go inside the smoke solver, you can see the root of it all it's a multi-solver, and all those connections just come to the second input. So at the end of the day, it's kind of simple, but the complexity comes by all the things that it does. So it's not really that complex again. So you can see some branches, this is updates the velocity and all that stuff. So let's see, external forces, calculates the velocity of field, this one is for gas blur for viscosity. Let's see if we can actually use one of these. Let's try this gas blur. Let's see if we can apply that to our current simulation here. And gas blur, let's see, GB works, gas blur, yeah. And actually this guy, we can actually just plug it there to the multi-solver as well. We don't need to do anything fancy or whatever. So if you want to do something special with your simulation, like making your own solver for something specific, you can just plug microsolvers. These guys are called microsolvers, and I love the icons of them. That icon, it's pretty cool. I love that icon. You can create these microsolvers and plug them directly to your multi-solver and create your own kind of behavior. So let's we need to move some fields. So in this case we don't have bell, but we have B. So let's try using B. Let's see if it works. And this needs to be set always because we wanted to calculate every frame. And I'm not even sure if this is gonna work. So let's see, we crank it up. Gas blur, is it working? Let's remove this guy. Let's see, let's disable it. I don't think it's working. Sub outputs. Let's see. Oh, I'm on the wrong one. Set always. Time scale. Let's see if we can reduce the time scale and something happens. Nah. Trace mask. This is the F. Let's see what it's doing here in the. The thing is that this might not work for this kind of a field. It might require a field of a volume field, but we can put some other stuff. Like let's say we want to say what is inside the flip solver, and let's go inside, and you can see again the multi-solver is the dad of everyone. You can see the multi-solver is just basically the solver, and on top of it, every other solver is built. This is not the behavior. It doesn't have any behavior. It's basically just like an output, like a container, let's say. And the behavior is all these guys here. So let's see if we can actually do something. Let's say we have here the particle forces. There's even a sub solver here for something. Match field with new value, particle velocity. You can see the particle velocity. It's just a pop solver there. Volume setup. We don't need that. Let's see. This is the solve part. We can actually update viscosity. This is a particle to field. It takes a viscosity field. Yeah, and it's a field. Stick on collision. Let's try this stick on collision. Maybe we can use that. Stick on collision. Let's say we want to stick on collision, and it's saying something. It's gone. Collision velocity. It's gonna be bell. Let's see if it works. Yeah, these guys are more to use with fields. You can see it needs a field here, and we don't have any fields with this. We're just working with particles, but yeah, that you can plug more stuff here. Let's say what? Yeah, we can let's plug the flip solver. Let's see if it works here. Flip solver, and let's run it, and it's working. But the area is too small. I think it's calculating this little small chunk. The flip solver, let's see, needs a boundary, I think, that we're not giving it. But you can do crazy stuff with this. Boundaries, where are you? Time scale, vorticity rest. Something weird is happening, but yeah, you can create weird effects with just doing stuff like this. Volume limits. Let's see if this is the limits that we're seeing there. Seems like it's not. Okay, now yeah, so not everything is gonna just work out of the box, because oh yeah, this needs a different type of object, requires some data and stuff. So yeah, but if you provide this data that the attribute that the solver needs, it should be able to work. And you can go inside those solvers and see what you can graph from that, and make your own thing, or remove stuff. But basically that's how the multi-solver works. And you can see we created something that it just, you can create whatever you want here. And you can see now we have a ground plane. We can even move that ground plane if we want. We can get could I add a sign function here? Seems like I can. Let's see if that works. Yes, it does. It really works. You can see now the floor is just changing every frame. It does work. So yeah, basically you can do just about whatever you want there. That's insane. You can do that, but okay. And also because I'm not modifying the x and z direction, the particles are supposed to, seems like they're sliding because they still have velocity. But we can even reduce the velocity. We kind of doing like a drag force here. Multiply the velocity by 0.99. So I'm gonna be reducing the velocity every time. So now you can see I kind of gave them a little bit of drag. Let's see if I can make that more intense. I don't want to save. So yeah, you can see now the particles are not moving as fast. Basically, I just gave them drag, and that's what the drag function does. If you see the pop drag, this guy, that's what it does. It just every frame it multiplies the velocity by a smaller number, and gives you that kind of particles that are stopping. You can see they are now moving a little bit more, but they go to a stop. And cool. So yeah, you can combine these two with whatever other solvers you want, and hopefully this opens up a few ideas for you guys. So let's see. AA is already said about mobs. I don't know the mobs plugin. I installed it, but I haven't used it, so I can't talk about it like an expert because I'm not. So let's see, webinars. Let me save this scene. Save this as multi LearnDay 60 multi solver. And let's start a new scene. See what else we can do. Discard and save a new. Yeah, save it. So yeah, mobs. I am not on any kind of an expert on it, but we can try to do something. I think I saw a few of the videos there. Let's create an instancer, and the instancer, I think you just provide geometry like this one, and then you instance the geometry with that, and then you tweak parameters, and it's pretty nice actually. I'm pretty happy with they did this mobs thingy because I think a lot of people are gonna be happy about this distribution. You can have different distributions on a sphere. That looks pretty cool. Let's try to do it order. Now that doesn't matter here. That's just the indexing. You can also fill the sphere. That's pretty cool. That's pretty rad. I wish they wouldn't. They had like an option to not have them collide. That would be a nice thing. If you would be able to not intersect the boxes. That will be nice. Then to this you can apply the modifier stuff. It's basically, if you guys ever played with cinema, how's that called? MoGraph? Then this is very similar to that. I don't know, transform modifier. Again, I'm not an expert of this. Transforms should be, let's say, let's kind of scale these guys, and then you can have a fall off. Fall object fall off. And this is the pact, and this is the geo. Let's create a sphere. Let's see if this is how it works. What is this sphere I'm talking about? There. Do I do this after the fall off? Yes. Seems like. Yeah, so that is seems like it's working. Let's make those boxes really big here and really small here. So yeah, that works. That's, again, if you have used cinema, this is basically how those things work. Like, you create a fall off, you create an object that it's gonna control what you are adding here. So basically it's kind of a stacked kind of thing, layered. I can move these guys to up, maybe. So yeah, it's pretty nice that they did this, and I told Maurice that they were the right guys to do this. A few people have talked about how to do this, but I think they were the right people to do it. I want to use this more, but I don't really know. I haven't played with it. I've been really busy, but I think it's pretty nice what they're doing. AA is also talking about Openstreetmap. The Openstreetmap is part of the game dev tools. So you need to have the game dev tools. If you go to the shelves, there should be a game dev tool included here with Houdini. If you enable that and you don't have this installed, you should. There's an icon here to install it. So you need to install the game dev tools if you want to use the Openstreetmap thingy. Again, I haven't used it because I don't really use that kind of stuff, or I use it when I need to, but I haven't needed. So let me restart Houdini. Let's see, discard and quit, and let's bring on Houdini again. And we should have the updated version of the game tools now. So game tools now it's updated and it should be available, I don't know, somewhere here, or maybe just here it is, OSM Importer. You can see, you click that thing, Openstreetmap Importer, put it there, and then you just give it your OSM file. Let's download some of that thing. Let's see if we can figure it out here. Openstreetmap. Let's get some area here. Let's go. Let's see. Can I have something maybe close to my house? This is the area where I live. I'm not sure if it's gonna work, but I don't know. There's some houses here. Let's see if it works. There was a way to get this. Export, here it is, and then I grab an area. Manually select an area. Let's try that area and let's export. Let's see if there's something there. Maybe there's no info in that area. LearnDay webinars project. Let's call this OSM and save that. And let's go back to Houdini and let's save this file. I didn't set the project to the one we were working on. So let's save it and let's say LD LearnDay 60 OSM. So now let's grab that file that we exported. Where is it? Project OSM. And let's see, there we go. You can see there it is. That's the map that we just exported for OSM. There are, I think there's a tool to generate buildings, but I don't know. You can see there is buildings beta. Well, let's try that. Let's see how it works. Buildings. There we go. And should I just connect this? Generate buildings for missing data. There we go. It's generating buildings already. But of course this area that I picked was maybe too it's not somewhere that they have built this or whatever. So, but yeah, that's how you import stuff from OSM with the new tools that Luis and the game dev tools team are building. And you can do whatever you want with that data once it's inside Houdini. Bob says, want to use the knife tool. All right, the knife tool. You've been asking in the forum. I remember, Bob. I want to use my Wacom tablet. So let's create a box. I don't know why you're trying to slice, Bob, but the knife tool just works like a line that it's cutting something. So if you put a knife there, you can see it's just the surface that it's just cutting along a plane. If you want to keep both sides, you just keep here both sides, but it's still gonna be split. But you're keeping both sides if that's what you want. If you want to do it that for a character or whatever, you might want to do that. Just keep both sides, and maybe even yeah, have those points like that. Don't remove the points. Don't do the clip unconnected, I think it is. Let's see, with a subdivide. Nah, it doesn't matter. If you keep both sides, seems like it's just fused together. Okay. Yes, my new shortcuts work. Cool. Showing normals. Showing point numbers. Showing points. What was this? I haven't done that one, I think. Cool. Let's say, what else is there? You might need to reset your Redshift environment bars after installing the game dev tools. I don't know that, Bob. Well, the knife tool is basically the clip tool. It's basically the same thing. It's basically the same thing. It's exactly the same thing. You can see it's the same thing. But the knife tool has an interactive mode. Like, you can actually do this with the knife tool. You can see you can actually select the plane you're in cut with. Let's see. Bob says, say a 10 by 10 grid with 100 polys. Select 4 in the middle and make cuts on them. Make cuts on them. Let's say a grid. It's 10 by 10. Select 4 in the middle, like that. And then cut on them. Maybe what you want is just a loop, dude. Maybe you want the edge loop, not this. You want maybe the let's go to the poly modeling. The edge loop can do several cuts here, and you can see number of loops. Let's say you want all those cuts, you can do that. You can see you can create several loops at once there. I don't know why. Should just this tool should just work on the polygons we have selected, but seems like it doesn't. But it should. We could just trick it by hiding those visibility. Let's show hide everything else and then do that with an edge loop. Let's say I want 5 cuts in this direction. It's cutting everything still. Damn it. That should work. That should be that should be a request. The polysplit needs a group. I think needs a group entrance there to just divide whatever you're selecting. Yeah, but with the knife tool, I think it should work. With the knife tool, if you just do let's see if my tool works. I haven't tested with knife. Let's see, let's cut here. It does work. You can see that it just divided that. So if you press Q, you can put another cut. If you press Q, you can put another cut. If you press Q, you can put another cut. It's that what if that's what you want, that's how you do it. If you just wanna do the edge loops should work with a group. It needs a group parameter actually. That's a nice request. You should request that. With the map, will it be possible to get real-time public transport data and map it live? Like buses moving in real time? I don't know where you can get the data, man. You could. Hey John, yeah, you're late, man. We're almost about to end. Hi John. But yeah, if you can get the data from somewhere, AA, you can map it for sure. There's Python. You can map it with Python, get the data, and move it around. I don't see why not, but you need the source for the data, and I don't think Openstreetmap gives you that data. I don't think anyone will give you public transport data live. I don't think anyone will give you that for free, at least. Maybe you can GPS your car and try that, put it in a Python API and bring it to Houdini. But yeah, I don't know where you could get that data actually. Oh, I wanted to tell you guys about another thing. So let's go to texture, which is a new page. Which is called Texture Heaven or Heaven. How do you say that? It's not heaven. It's heaven. Is it heaven? Is it heaven? Heaven. Let's say, is that an actual word? I don't know what that word means. Haven. Anyway. Texture Haven. It's a new website with free textures. They are CC0, so you don't have to give them any. You don't have to say whatever to them. You can just use it freely. They are running a campaign on Patreon, and you should actually support them. I already support the guys from HDR Heaven, which is great. And the textures, there's a few textures. The page is really new, but there's a few textures that are really cool. They have all the the maps for PBR texturing, like the roughness and all that stuff. Sorry. So there's a few textures, but they are say they're gonna be adding more textures, And yeah, it's pretty cool, free resource for textures. You can do a bunch of stuff with these textures, mixing it up, having a play with them. So that's another thing I wanted to mention. What else? Are there any other questions, guys? Any other questions? Let me switch to my big camera. Any other questions before we wrap it up? Hope you found that multi-servers and dynamics information useful. It's something that not everyone knows, and it's gonna be helpful for you once you know that stuff. Okay, so no questions. Should we just wrap it up? Can I talk about my giveaway? Well, that was last week, and the giveaway is when you support us on Patreon with $10 or more. Some training it's given away to a random subscriber, and you can pick whatever training from our site. No bundles, just as one single title. And so that's how it works. If you are just the lucky winner, you can get training for cheap, or even just because of supporting us, you can get just extra training. Kevin, yeah, this will be posted on YouTube as soon as we finish. Those textures work on Redshift, should work on Redshift, or why not? They're just image files. Yeah, they should work. Alright guys, so that's gonna be it for today. Thank you for joining me, and I will see you next week. Let's keep learning together, and let's do awesome stuff. Alright, see you guys next week. Take it easy. Yeah, maybe we talk about Jumanji sometime. I haven't prepared something for that. Alright guys, see you later. Bye.